Hi John, I thought of sending another video, the one I pre-recorded before, but the spreadsheet's moved on a little bit since then. So as a result, I might as well do another one. Here is the spreadsheet. Now the spreadsheet started off calculating the loads on these beams here. You know, if that beam there and that beam there, that's where it started off, and it's kind of grown since then over the past 6-7 months or so. But basically what it does structural timber members, which basically replaces the tables, you know, the Trada tables, plus a couple of extras. There's an extra purlin in there, a situation that crops up regular, and there's a floor joist that also picks up a partition. So that's a little bit different. Foundations, it picks up, it does eccentric foundations, and it also does pad foundations with an eccentric load on them. It does U-value calculations through that type of roof, whether it's between and under or multifoils. It doesn't do over-the-top insulation, although I could quite easily put a sheet together to do that. So it does that. It does cavity walls at the moment, and it does flat roofs, warm and cold deck. But the engine room's in position, so there's floors to do, there's floors to finish off. But again, because the engine room is in position, it's very easy to change it for specific locations. The fire safety and dynamics is basically unprotected area. There's a little bit on part B in there that I've been working on. That's probably the toughest program I've ever worked on, because it works with letters rather than numbers, and computers don't like working with letters. They love numbers, but they're not a great lover of letters. In fact, letters is just characterized in computer language as numbers. Bit on drainage, just soakaways in there at the moment, but I was going to do a self-cleansing velocity thing and pipe drainage for when, you know, on bigger estates. But I don't know how useful that will be. But I did get an inquiry about it the other day. When somebody said, one of the young guys said, the gradient's very flat, is that okay? And so I said, well, go away and find out and tell me. And in the meantime, you know, research self-cleansing velocity, and with a bit of luck, you'll add it all together and you'll decide yourself whether the drain is adequate or not. He hasn't come back to me yet. He must have got bored. And then materials. My view on materials is, as sooner or later I'm going to put a massive database together with materials. At the moment, it's kind of all over the shop a little bit, but mainly K values to particular products for the drop-down menus and stuff. But what it'll look like when it's finished, it'll be more like that, like a material, its melting point, its specific heat capacity, its K value, thermal conductivity, its density, pilot ignition, its heat, pilot ignition, its temperature, delta H, which is heat of combustion, flash point, and whatever values that you want to create for a particular material, and just fill in. And we can use it using pivot tables and in Excel. Excel is the greatest application the world's ever seen, and it literally does everything. The only thing it doesn't do is doesn't put a good front end on it. And the other thing it doesn't do is that if you put macros into it, i.e. little tiny programs, it won't work on an iPad. And that's why basically it's going to end up having to be turned into an application. So that's that anyway. So I'll start off I think you've probably already seen the structural timber members. I'll just run through one quickly. Everybody loves a floor joist, but they're all in there. So the floor joist, anything in yellow, you must fill in. So we'll stick in 3.8 meters. Centers, let's be bold and let's put 300 centers. Let's try 170 by 38, and straight away it's unsatisfactory. Now forget about that for the time being. We just pop down onto the construction. Now that the construction is what the columns in the Trada tables. I've never seen the Trada tables, never used them in all of my life. I've always had something like this to deal with timber members. I've never opened the tables up, except for when I've been shown other people them. But that number there is basically what the tables are trying to ascertain. It'll give you I think it gives you three tables: under 50 kilograms a square metre, between 50 and 75, and between 75. And I think it might even be 125 to take into account sound insulation and all that kind of malarkey. But anything that's in this kind of horrible pinky colour, you can change. So if you want to use 18mm chipboard, and you can see it'll change it. If you want to probably get away with 12mm because you're at 300 centers. Obviously if it's straight edge you would need noggins to pick up the edges because of fire resistance and stuff like that. So as you can see, it's calculated down to the wire. You'll find that a lot of engineers don't go this tight with the load-ins. Even to the point, you can put your timber sizes in there, and that makes a difference. So it will go, and of course you can have as many layers of plasterboard on there as you want, depending upon it may need fire resistance. It may need fire resistance. It may need sound resistance, and there's a contingency in there if you're using something like a reduct flooring system. So that reduct flooring system might have 2 layers of plasterboard, and it may have a layer underneath the timber decking, and it'll tell you in the instructions what the weight is. Say for argument's sake it's 15, and you would stick it in there and it would pick it all up. But we won't do any of that malarkey. We'll just keep it at 1 layer of plasterboard. And it's going to be around, and we'll pop that back up to 22mm chipboard. Okay, so at 3.8, 170 by 38 isn't going to work. Let's try 47s, and you'll see all of this malarkey all change. And there we go, it's okay. Let's try the 350 centers. Straight away it's unsatisfactory. What if it was at 320 centers? So you can play around with this. We can play around with the centers, especially on loft conversions, and never go in at 400 centers because the existing members are something like anywhere between 340s and 380s in my experience when I've been designing them. I've never found those joists very rarely go in at 400 centers. Well, they'll go in at 400 centers, they do because of the decking, but it can get a little bit. You can mess around a little bit with the centers on lofts. So the floor construction is there. That's permanent load, variable load. Everything's there. All of this malarkey was for me. And for people who want to check this, or alternatively, you might want to throw this into Superbeam. In which case, if you use Superbeam, you would enter this number. If you were using Eurobeam, you would enter those two numbers as the dead and the imposed load. That should actually, you would use the dead and the imposed load, or the permanent action and the variable action. So all of that's kind of for me. Those, again, if for somebody who wants to check it, those are the values that's been used. And so, if somebody said, floor joist, should you really be using a medium-term load. Well, if you don't want to use that as a medium-term load, you can change that to 1, and all that will change. So, but that, like I say, it's predominantly a checking. That's predominantly a checking mechanism. You would have a go to purling, and again, what's the use? I'll do the rafter and the purling, because the rafter and the purling is quite interesting. The rafter, again, you work. If people are used to working on slopes, rafters are designed on plan, but if people are used to working on slopes, then fine. So if the slope dimension's 2 meters, for argument's sake, the centres is 400, but we could put 450s in, because we can do that. Trial depth, trial width, pitch of the roof, well, it's not going to be 17 degrees, it may not be 17 degrees, it may be, I don't know, 25 for argument's sake. And you see straight away by changing the pitch of the roof that the rafter then turns satisfactory. Then it's just a matter of, on the roof construction, making sure that your loading is right. And again, if it's concrete, let's pump it up to 35 degrees for a giggle. And the reason I put it up to 35 degrees is now we can use plain tiles. And 2 meters for you. If this is just for loading, so it's how heavy the rafters are. Now, if it's a roof without plasterboard, then you take the plasterboard away, and instantly that'll go to 0. So that will be just for a straight roof, no diddly ceiling lining, and so there's the load, and we're okay with 100. It should be 97s to be fair. 97 by 47 C24 rafters. Would we get away with C16s? I reckon not. No, you won't. So there's a 24, and so we've already put the load in. We've already got the rafters. So we then can go down straight onto the purling, and we can check the purling because it's got exactly the same loads. So let's assume it's got a span of, I don't know, 2.8 meters. Little diagram here that shows you how to calculate this spacing, and it's the same as the tables, only you multiply it up by 1.25. Now I don't know if the tables already take this into account, but it takes into account what's called elastic shear, and it's a factor that only applies if you are supporting a continuous member. So if that rafter went from plate to purling and from purling to ridge, then you wouldn't put that 1.25 in. You put the 1.25 in because that member is continuous. And when it's continuous, that centre member attracts proportionally more load than the outside. That's basically structural mechanics. But let's say for argument's sake that the roof is 8 meters from plate to plate, then that distance there is going to be 2 meters. You multiply that by 1.25, which when I went to school, that will give 2.5. So you put 2.5 in there. And we've got a trial depth in there of 2. Let's try 200 by 75. See how that works. Unsatisfactory. So it's 220 by 75, and that's okay. So 220 by 75. You can check this out on the tables. But this is basically, this mirrors super beam. So whatever if you inputted the data into super beam, then you will get exactly the same comeback. So again, what's in red is Big Dummy's guide. What is on the outside, that's the loading, the unfactored loading. If you want to get into it a little bit more detail, that's a factored loading, which you factor up in accordance with the Euro codes, or you factor up in accordance with the limit state codes. All of this is the stresses and the deflections, and all of this lot is load factors. which again it's all there for checking. So if I get a stupid answer, I can figure out exactly where that answer's come from. So that's basically the purlin check. And that works effectively for anything. You stick a ceiling joist in. Again, whatever's in yellow, you fill in. Whatever's in lilac or whatever hell the colour is, you will you can change it. And that's a ceiling. It may have a decking on it. So in this case, it says none, but somebody might want to put a decking on it. In this case, I might stick 18mm chipboard in, so the weight goes up. And for some reason, there's 2 layers of plasterboard on there, but generally there'll only be 1. And 150 ceiling joists, you don't see them anymore. People end up using 6x2s because I don't know, they don't like using binders or whatever. But that seems to be the norm these days. And again, in this case, joist satisfactory. It's only spanning 1 point. If you make it span 3 meters, of course, it's not going to be. Put that up to 147. See what happens then. Joist satisfactory. So that's basically how the thing works, and it works for all of this. That's that purlin situation I was talking about, which is slightly different. You won't see that in the tables. And the floor joist and stud works much the same. Well, it doesn't. I was going to say much the same as the purlin, but the purlin that you've just seen. But that's. So you'll put your data in, you'll check your floor construction, you'll check your partition construction, and then whatever the span turns out to be, it'll be fine. And this one we'll run through 4 meters. Floor joists at 400 centers. Trial depth we want to go 300. Go 197s, and well 297s even. 197, 94. How does that look? Does that like that? Choice that's unsatisfactory. Let's have a look at the loads. 22mm chipboard, 200x50 timbers, 1 layer of plasterboard, so that the floor load's okay. Partition, 1 layer of plasterboard, 100x50 timbers, 1 layer of plasterboard, insulation, so that the loads are normal. So, and that 2 number 197 by 47s isn't good enough. You need to put the number of members in here. If you only have 1 member, you'd only put 1 in there. So let's up that to C24s, and it's still not good enough. So you might need the 3rd member if all of your members are at 197s. So that's 141 when I went to school. And of course, as you'd expect, the joists are satisfactory. That was three 8, but well, effectively three 8x2s, 3 197s by 47s. But you know, if you thought, okay, we'll pump it up to 200s, and we'll put 240s by 220s by 94s, then again, joist was satisfactory. Could you drop that down to C16s? No, you couldn't. So again, this is all based off super beam, so it's a little bit more economic than the tables. But like I said, I've done a lot of testing on this. It's close to the mark, but I still need to do a little bit more before I release it. It's just a matter of getting all of this right in principle first. So that's more or less the structural design. This part here is for designing loads on these beams, and it's, you know, it's beyond. It's simple to do, but you end up with a number that you have to put into super beam or you have to put into Eurobeam. So I'm not going to go into that. That's probably the best part of the program. Anywhere, because that makes life so much easier. And that was a program that I wrote in the 1980s, but I did it in BASIC rather than Excel and VBA macros, which I'm nowhere near as good at. I'm learning VBA as I go along, to be fair. Right, return to members. we'll go, the foundation one uses the loading program, and we virtually need to run through that. That one there is a standalone for the column. If you know the column, if you know the column dimension, the column load, then it'll work out the bearing at the underside, which is just a straight load over area, unless there's an eccentricity on it. It'll work the eccentricity out, but only in one dimension. Not really. This isn't really fully developed yet. This is another thing. This is one of the things I'm going to be working on. The U values there or thereabouts. This is what Trevor has been commenting on, and this is rafter with insulation under, and so basically.
Okay, I found this on the web for his rafter with insulation. Check it out.
That's Siri on the iPhone. Right, this is, like I'm saying, start at the top if it's in yellow. Rafter depth, well, they're normally 150s, but let's do things properly. They're normally 147s for 47s, regularized timber, 400 centers. It's going to follow that particular pattern. That's the pattern for multifoils, because this was part of the same spreadsheet. And Trevor said, no, don't have it as the same spreadsheet. Too difficult. Make two spreadsheets. So I split the spreadsheets in half. First thing you're going to do is to reset the drops and reset the thickness. And the only thing that will be left will be the rafter depth, because we're going to use the rafter depth that forms part of the U value calculation. And now you're just working from left to right. So surface resistance, that's cast in tablets, so an external surface resistance 0.04. Roof covering, choose from the list. Concrete slates, whatever, 10 millimeters thick. If it's a concrete locking tile, that's probably reasonable. Batten, so we now go left to right again. Batten cavity, yes, there is a batten cavity, and that is ventilated. Is a rafter cavity? Yes, there's a rafter cavity. That sits underneath the breather membrane. So we saying that that's unventilated cavity, so it gets a little bit of a bigger R value. Between insulation, again, choose from the list, whatever you want to choose. Kingspan, Celotex, or there's a couple of generics in there in case somebody wants to use styrofoam or something like that, something ridiculous. And I can add to this if people say, oh, you forgot about Rensel's whatever super duper insulations. 2-second job to add it onto the list. So we'll say it's GA 400, and we'll say that's 100 millimeters. Surprise, surprise. Again, left to right, rafter. We've already dealt with that, and we've already got a K value for that. We don't do anything in that because that's already taken into account the centers and the bridges and all of that. So that's the R value for the insulation, that's the R value for the rafter, and that's the modified R value, taking the pair of them into account. So the bigger the centers, the smaller, the closer these two numbers are going to be together. But if I put in there 200 centers, then you'll see that this number will drop. See how it drops because there's a lot of timber there and there's a little less insulation. Or if you turn that to 600 centers, then again you'll see that rise to a lot closer to that. So I'll stick it back to 400 and you'll see that. Then the under insulation, again, choose the list, and it might be somebody wants to use one of those Moody insulated plasterboards, and the K value of the insulation is only 0.035. God knows what the make is, and they might want to use 50 millimeters of that. And the internal board, that'll be just, either plasterboard, lightweight plaster, but it's not going to be lightweight plaster, 12 millimeters. And you'll see all of this is all changing. Finish, choose from the list, need skim. So everything's working left to right. So it works left to right, so down, left to right, just as if you're reading a book, and so that's 3 millimeters, and the U value of that is 0.19. So it's but I haven't managed to make that sound yet. My programming skills don't extend to moody sounds. So you might have to put 60 millimeters under insulation of that poor, and there you go. Back to that's at 0.1. That's at 0.18. Or alternatively, you can go to Celotex and drop that back down to 40 millimeters, and that should do it, which it does. So that's how that works. There's a couple of modification factors in there, but like I say, the thing is that it's a little bit more economical than the Celotex website, because I don't think the Celotex website takes these cavities into account, which do actually exist. But like I'm saying, it's still in the development stage as it stands at the moment. So that's the rafter between. We can the multifoil works much the same way. Again, external surface resistance, casting tablets, roof covering. We can run through it a little bit quicker. 10 millimeters. If it's a slate, for argument's sake, it might only be 6 millimeters if it's a slate, 6 millimeters if it's only a slate, or if it's plain tiles, it could be 25 millimeters because there'll be 3 tiles together. So all of this kind of makes a difference. Makes a difference between it failing sometimes and passing. But if it's a concrete interlocking tile, I normally just assume 10. The batten cavity is ventilated. The rafter cavity is unventilated. The in-between insulation, they're generally going for 80 millimeters these days, I think, with the multifoils. The rafter, like I say, you don't touch that because that's all modified in accordance with that. And then we get on the blue bit, all relates to the multifoil. Now, the low E cavities that I've given this is what I've got out of the BRE digests. The low E cavities that the likes of the multifoil manufacturers are taking into account are much higher. They go as high as 0.5. But I'm kind of making this work with the real ones. And as far as the multifoils are concerned, I'm using the core R values. So not these inflated full R values. It takes into account the cavities, because this program takes into account the cavities. So you're seeing the multifoil, the super quilt, and the super quilt R value, the core R value that's been subject to the hotbox test is only about 1.5, the R value. The better quilts, I think, is it TLX Silver? Which one of them goes up to? Yeah, this Actis Control Hybrid goes up to 1.9, and then they stick their two cavity values in, and it pushes it up to almost 3. Which is insane. But like I'm saying, we'll just go back to the YBS Super Quilt, and we'll give that another low E cavity. And then internal board, just the same, plasterboard, 12 millimeters, finish 3 millimeters. And there I've got that to work. And that's not using their low E values of 0.5. So, and that's with an 80 millimeters of now they may be trying to get away with 75, which will push it up a bit. Obviously goes over the 0.18, but if it just depends. If there's no roof lights, that would be absolutely fine, because that assumes, the 0.18 assumes 25% roof lights. there isn't 25% roof height, you're allowed to push that up a little bit. So you know, so that's the include the multifoils. Warm deck flat roof, again just fill it in, fill that one in left to right all the way down until you get your value. Cold deck roof, exactly the same. Cavity wall, exactly the same. That's the most complex wall that it will do. So that will be cladding, cavity, insulation, masonry, partial fill cavity, insulation, masonry, insulation, cavity, lining and finish. And so if it applies, you choose from the list. If it doesn't apply, just don't, you know, if there's no cladding, then don't touch it. If there's no insulation, don't touch it. No cavity. If it starts off with brickwork on the outside, you would start at this point here. So at that point, you would say, right, facing brickwork, 100 millimeters. Cavity. There's no cavity. It's full fill. So we drop down the list and rock wool flexi, and that's 100 millimeters. And then the masonry in a leaf. Try Selcon shield, 100 millimeters. And it's just lightweight plaster, so there's no cavity, there's no insulation on dabs, there's no insulation between battens, just pure says insulation board there. I've got to change that. Lightweight plaster, 12 millimeters. Finish, need skim, 3, and that gives 0.28. So you might need to it's close enough. 284 is close enough. It's close you're ever going to get. So that's a kind of, you know, and obviously if you went to Selcon Solar, must be further up. You went to Selcon Solar, it'll be, you know, it's well inside. So that's how that fella works. And obviously it'll take render, it'll take cladding, it'll take, you know, insulation on the inside and all of this kind of stuff, but you can play with that. And then you can again just reset the drop downs, reset all of the thicknesses, and then off you go again. Return to menu. So that's more or less that done. Fire safety, haven't got any flash pictures for this yet. Space separation, pretty much simple. Put your openings in. You know, I've got one opening. One is 2 meters by 1.2, and my next opening is 2 meters by patio door by 2.1 high. Then we've got a kitchen window, I don't know, 1.2, and that might be 0.9 high. And there's our total. That may be our total at 7.68. So you put your 7.68 in there, or 7.7. I'm not going to do unprotected areas to 2 decimal places because that's damned insane. And our enclosing rectangle may be, well, maybe 9 by. It may be a house where there's no compartmentation, so it might be 9 by 6. 14% unprotected area. And reduced fire load, because we may have a standard fire load for shops. Standard fire load offices is reduced fire load, so the fire load can change. That would probably, if that's a 6 meter high, we'd probably have what have we got there? We'd probably have another bedroom window in there. I don't know, another 2 by 1.2. So that would probably, let's take that up to, well, we'll say 10.1, and you'll see this change. And you can pull, if you, this is the graph that all of these numbers is based on. Well, that's standard fire load. Let's reduce the fire load for domestic, so it needs 1.7 meters to the boundary. And So you can if you think, oh, I don't think that's right, you can check it by looking on the on the graph. But basically, what I did, I worked out the equations from because that's a straight line from there to there. That's a straight line from there to there. That's a straight line from there to there. So I worked out the 4 different equations to get these numbers, and they're pretty accurate. I've checked it over and over again, and it seems to be about right. So that's that fella. This was me messing around a little bit. It's estimates the maximum compartment temperature, and it's something that kind of picks up in BR 187, and it's a good estimation of whether you should use the standard fire load or the reduced fire load. In reality, guidance tells you what you should use, but it's always it's interesting to know the reasoning behind it all. So this is basically, you just put in the size of your compartment. If your compartment is typical flat might be 8 meters long, 6 meters. Height of the compartment is 2.4, and basically now you just stick the length of the length of the opening in. I don't know, that might be 4. The height might be 2, and that obviously all that works out, and it's basically that opening factor there. That opening factor there, if it's around about 11, that pushes the temperature up. If that's around about 11, it pushes the temperature up, and then you really should be using the standard fire loads rather than the reduced ones. If this is just 1 meter by 1 meter, then you'll see that the compartment temperature, it drops right away down, because the fire in that compartment would be ventilation controlled. It just wouldn't get enough oxygen in there to get it any temperature. And if you had that situation, it's good reason to say, oh, we'll use the reduced fire loads, irrespective of what it says in the guidance. But obviously, there's not many people that's got the balls to do that. But it's just something that caught my eye when I saw it, and I thought, oh, it'd be interesting to have it in there as a little spreadsheet. And the ADB data, this is probably the toughest thing I've ever worked on. So whatever your purpose group, so if you want to put an office in the unsprinkled office, and it's 4 meters, four stories, and it's between 5 meters and 18 meters, and it'll give you the fire resistance, maximum compartment size, travel distances. That's where it assumes a risk profile under 9999, and this is separate. If you put that in, that will also give you your floor space factors here and the recommended alarm and BS in BS 9999, because obviously there's no recommendation of what category of fire alarm you should use in ADB. That's a work in progress, but for commercials it's pretty much done. And if you were say I think if I remember rightly, it's pretty much done on the dwelling side. So if you had a 3-story dwelling, and the 3-story dwelling is less than 5 meters high, and floor area 66, forget about that. The reason why that's separate, it's in red, is that you've got to deal with that separately. And as you see, the second a dwelling comes up, it doesn't give a floor factor, so that's already cancelled out. So then you get to single occupancy dwellings. Is it an enclosed staircase? Yes, it's enclosed. Protected route, FD20s, every habitable room. FR, compartment walls, protected route, FD with FD20s, or EFD every habitable room with panel. So those are the two. If you take open staircase, suppression, separation of ground floor, egress windows. So it'll take all of that into account. So if you went to 2-story, this will change. See, staircase okay with egress windows. So it's the idea is with this, the whole sheet is it's an audit trail as well. So it's you could fill this in for every job, and then when you're finished, you plonk it on Tascomi. So it's got all it'll have everything, all the major decisions that needs to be made will all be located on it. Fire drainage. I haven't done pipe capacity, but there's a soakaway design on there. Area to be drained, infiltration rate, that's always going to be low. It'll depend on a BRE 365 infiltration test, but I tend to use that number there, and that's quite a heavy clay. So you can put your various stick 100 square meters in, which isn't unusual for a new house. And up will come depending upon whether you're using a 5-year storm or a 10-year storm, and there are the sizes of the potential sizes of your soakaways. So for this, for 100 square meter new dwelling, you're looking roughly for a 3.5 cubic meter soakaway, which will deal with a 10-year storm at 240 minutes. Now the reason why it's high on 240 minutes is because the infiltration rate is so low. But if they came up with a better infiltration rate, if you knocked a couple of zeros off that, then you'll see everything drops down. So you can play this on the safe side and say, right, okay, yeah, you need 3.5 cubic meters, but if you do a 365 test on it, and it turns out, the infiltration rate is half of what I've taken, then we can take that into account. So I've used this probably for 5 years. That's why it's still got the R value based on Uttlesford's rainfall. But here in Uttlesford, it's roughly the same. It's a bit drier in Uttlesford. In fact, I think everywhere is fucking drier than Welwyn Garden City, to be fair. I think it just rains here all of the time, and I don't know why. I've never lived anywhere as wet as this place, but I love the town. But there you go. And that's it. And hopefully, and it will grow. And I think I've got another 6 months of development on it. But anything that you can think, oh, it'd be good if it did this, or I don't quite like the way it does that. Perhaps it would be better if it did this, or the drop-down menus could involve, could use a different material or whatever. Anything is useful. And then the idea is that I distribute this to the spreadsheet will go to HBC for free, and I will develop the application that'll run on an iPad, and that people will have to pay for that, because it'll probably cost me about I think it's going to cost me about $3,000 to develop it. So obviously I've got to get that back, and if I make a bit of money, great. If I don't, well, I'll just have to cry in my beer. So that's it, John. Hope you enjoy playing around with it, and thanks for your time. All the best.